Let's take a look at a few examples from this lesson using our new laws of exponents. So we're going to first start with an example using our power of a power rule. So remember, that's telling us to take, in order to find that power of a power, we're going to multiply the exponent. So in this case, what we're really looking at is a base of 3, and then the 2 is being raised to the 5th power, which is just telling us to multiply the 2 times the 5. So if we're going to write, and we're just simplifying using the laws of exponents, we're going to leave our answers in exponential form for now. So it would be 3 to the 10th, or you could multiply that out and do 3 to the 10th, and then you would get 59,049. So depending on what the directions say, you might give either answer. So just when you're looking for this, you want to make sure you see, okay, what do I have as my base? Is it being raised to a second power? So in this case, the 3 is being raised to a 2, and then I have another power that's on top of that without any base in between. Alright, so let's take a look at number 2. It's very similar, but now I have a coefficient here. 7 is my coefficient to w. So what I'm doing here is applying the 3 to each term inside. So it's going to be 7 to the 3rd power times w to the 7th to the 3rd power, which really just means 7 times 3. Now, why didn't I write any multiplication of the 3 on the 7? Remember, when you have a plain number or variable, the invisible exponent is a 1. So really what I'm doing is 1 times 0, but when we're doing that, it just ends up being 3. So I'm going to take that step out. Now what I want to do is simplify what I have so far. So 7 to the 3rd power is going to be 7 times 7 times 7, which is 343. And then I'm going to have my variable here, and then I'm going to do 7 times 3, because that's what my rule says when I'm using a power to a power. So 7 times 3 is 21. So my final answer would be 343 w to the 21st power. Alright, so now we've looked at a power to a power rule. Let's take a look at what do we have, what happens when we have a power of a product. So we want to find the power of each factor and then multiply them. So in this case, I have 2 to the 3rd, to the 2nd, to the 3rd again. So what I really end up doing is just having my base of 2 raised to the 3rd being multiplied by 2. And if I do this in steps, I'll do the first step here, and we'll just work on what's inside. And we'll leave that extra cube out here. That's going to give me 2 to the 6th power. And I still have that 3rd out here. Well, once I get to this step, this looks very similar to what I did in numbers 1 and 2 for my example. So what it really breaks down to is 2 to the 6th times 3. So that's going to give me, I'm just kind of going to go backwards here, 2 to the 18th power. And we'll leave it like that just to make it a short cut since I ran out of room. But you could also evaluate that if you're trying to find a full number answer. Alright, so let's look at some more problems with variables in them. So another example of a power of a product. We have some products inside the parentheses. That means the 4 is getting applied to each piece. So the 4 is going to go on the 5, on the g to the 8th, and on the k to the 12th. So I'm going to rewrite the problem first, applying that 4 to each component, which when I'm raising that to a power, it just means that I'm going to multiply my exponents. Remember, that's a very common error that was in the presentation that you just watched. So what you want to do is make sure you're remembering to multiply those exponents when you are raising to a power. So 5 to the 4th is our first step. We're just going to do 5 to the 4th, which is 5 times 5 times 5 times 5, which ends up giving us 625. G to the 8th times 4, we're going to multiply those exponents. It's going to give me g to the 32nd power times k, and then 12 times 4 is 48. So k to the 48th power. So they're really big exponents, but that's okay. We're just making sure that we have taken all of our steps to apply those two different rules. So those are a few examples of using both of the rules, power of a power and the power of a product. So there's some more examples if you want to try them in the textbook online, or doing a quick the quick check for yourself, or if you have any questions, please stop into office hours.